We are from group AH110 2B, and my name is Muhammad Karizat Be'udwa, and our member is Hero, Kimi, and Zapang. First, for the question 34, we have f x y equal to or equation. For the first step 1, to get the fx, we must differentiate all equation or this equation, so we get fx. For next, to get the equation of f, for fxx equal, we must differentiate 16xy, so we get 16y. And next, to get the equation of y, we must differentiate from fx y, so we differentiate y, we get 16x plus 4. And next, for the fy, we must differentiate all equation again. So for the equation of y, we must differentiate from the fy, we must differentiate 2y, and we get 2. For the equation of x, and s, we must differentiate of x from the fy equation, so we get 16x plus 4. And that's all for step 1.
We have to find the critical value. To find the critical value, we choose the either fx equal to 0 or fy equal to 0. And in this equation, we choose the fx equal to 0. From this equation, we factorize the equation and we get the critical value y equal to 0 and s equal to -1/4.
Step 3, we need to find the critical points. We already have critical value that we get from step 2. In this equation, we got y equal to 0 and x equal to -1/4. And we need to substitute the critical value into the equation fy. If we, in the step 2, if we use fx equal to 0, we need to substitute into fy. But if we use fy equal to 0, we need to substitute into fx to get the critical point. Okay, in this question, we got y equal to 0, the critical value. We substitute y equal to 0 into the equation fy, and we get 2 critical points, 0 and 0, 0, -1/2, 0. And for x equal to -1/4, we substitute into equation fy, and then we get -1/4, 1/4. And then we get 3 critical points. And in order to check the critical points valid or not, we can substitute it into fx or fy. If we get 0, then it valid for both of equation. That's all.
Next, the step 4. The step 4, we already have the critical points 0, 0, -1/2, 0, and -1/4, 1/4. Next, we need to use the second partial derivative test formula to test whether it is saddle point, minimum point, maximum point, or no conclusion. If d is larger than 0, fxx is larger than 0, then f is minimum at a and b. If d larger than 0 and fxx is smaller than 0, then f is maximum at a and b. If d smaller than 0, it is saddle point at a and b. If d equal to 0, it is no conclusion that can be made, whether not maximum, no minimum, or saddle point. Then we need to create the table. The first table is critical points. Second table is fxx. Third table is fyy, and next table is fxy square. And next table is this formula. The second partial derivative test is d equal to fxx fyy minus fxy square. And the last table is conclusion. And as you can see, the critical point is 0, 0, and we substitute to the fx to the y, and we got 0. Then fyy is equal to fxy squared equal to 16, and we substitute into the second partial derivative test. We got negative 16, and the conclusion is saddle point. Next, the critical point is negative 1 over 2, 0, and we substitute to the y, and we got 0, and fyy is the same, is equal to, and fxy squared we got 16, and d we got negative 16, and also we got saddle point. The critical point is negative 1 over 4, 1 over 4, and we substitute into the y, we got fxx equal to 4, fyy equal to 2, fxy squared we got 0, and d we got 8, and the conclusion for the last is the minimum point. And that's all from me.